Good day, everyone. My name is Joshua Miguel Rebaño, a third year civil engineering student at the University of San Carlos. And today I will be discussing about two types of construction materials, which is wood and asphalt. So let's start off with wood. So first, we'll be talking about five topics of wood. First, the structure of wood. Second, the types of wood. Wood construction products for the third. Lumber versus timber for the fourth. And lastly, the mechanical properties and how to test it. How to test them, rather. So first, what is wood? I think it is very obvious for every one of us, to as to what wood is. So it comes from our trees. So it is an organic material with fibrous, heterogeneous, and anisotropic texture produced from tree, which is a living organism. So for the characteristics of wood, it is hygroscopic, which is the phenomenon of attracting and holding water molecules from the surrounding environment. It is also cellular because also it is a living organism. It is anisotropic, or having the physical property that has a different value when measured in different directions. So this is an example of an isotropic wood, which is a homogeneous and a heterogeneous wood. So next is the a sample of the log, which are the inner parts. First, we have the outer bark, the first layer, the second inner bark, which consists of the secondary phloem and cork cambium. Next is the vascular cambium, which is the ring here, and the yellow layers here are sapwood. The darker ones are called heartwood, and that its center is the pith. So these vertical diagonal lines here are called the rays, and these circular lines are called the growth rings. So in coniferous softwood species, the wood cells are mostly one of kind, and as a result of the material is much more uniform structure than that of most hardwood. So what are these softwood and hardwood species? Let's talk about that later. So also in samples of wood being used in construction, there are also these types of pictures here. I mean characteristics here, which are called knots, and this edge here is called the face grain. This one here is called the end grain, and this one is the edge grain. So let's move on to this. Since the source tree has been exposed to many factors in nature, especially when making it necessary for the trunk to have two material properties, the center is in compression and the outer layers are in tension, as portrayed here in this picture. So the physical properties of wood are three: density, the indicator of wood strength; the growth rate, or um, how the wood grows; and the moisture content, or the moisture will also affect its strength, because wood is weak, it is when wood is wet, it is dry. It is weak, and when it's dry, it is stronger. So there are two types of wood, which is hardwood and softwood. Hardwood are generally wood which are lose their leaves annually. Examples are beech, oak, ash, and teak. For softwood, they are trees that remain evergreen, which are pine, spruce, cedar, fir, for some examples. So these are some examples of common wood in the Philippines. From left to right: Kamagong, Dungon, Ipil, Dao, Tindalo, Mulawi, Giho, Nara, Langka, Saplungan, and Yakal. So let's move on to wood construction products. So glue laminated timber, or glue lam, which are composed of lams which are bonded together, which will make them durable; and plywood, which are mostly used in small furnitures and homes. Next is oriented strand board, made from waterproof heat-cured adhesive and rectangular-shaped wood strands that are arranged in cross-oriented layers. Next are cross-laminated timber. It consists of several layers of kiln-dried lumber boards stacked in alternating directions, bonded with structural adhesives, and pressed to form a solid, which makes it stronger. So also we have structural composite lumber, which is mainly used in beams and columns. And also we have S2S or S and S4S, which are surface two side, which means that two sides of this sample are smooth, or are being sandpaper to make it smooth, and surface on four sides are smooth on the four layers, I mean the four sides. Next we have the difference of lumber versus timber. So timber generally are wood that are over 5 inches thick and 5 inches wide, and are often used in bigger built infrastructures because of their size. And lumber are the smaller ones, which are smaller than 5 inches wide and 5 inches thick, which are mostly used for residential purposes. So what are the uses of lumber? So most commonly they are used in outdoor canopies, flooring, ceiling, and wall framing. They are also used in temporary structures such as scaffoldings and shutterings, and also for permanent structures such as bridges, fencings, and posts. So how do we measure lumber? So to measure lumber, we have these three dimensions, which are the width, length, and its thickness. we divide them by 12 so that we can get one board feet because we divide them by 12 because 1 foot is 12 inches. So generally one board foot is 1 foot long, 1 foot wide, and 1 inch thick. So the mechanical properties and tests of wood. So mainly we test them for their stiffness and elasticity, tensile strength, compressive or crushing strength, shear strength, transverse or bending strength, for beams, and toughness. And also we have hardness, cleavability, and resilience. So these are the tests of how to test wood. Tensile testing reduces screws and grip jaws and stretch them by moving the grips apart. Next, we have impact strength, which uses a pendulum. We also have Vickers, which uses a microscope. Micro hardness, which uses also uses Vickers, but uses also loop intenders for them. And also Brinell test, which uses large loads, which are up to 3,000 kilograms. We also have Rockwell test, which uses a mic- uh, penetration test for them, and also rebound test, electronic rebound test, which uses this type of machine, and also the scratch or moss test. So we also have different factors that might affect or degrade wood, which are natural causes, fungi, bacteria, and insects, which is very common here in our homes. Next, we have also exposure to light, exposure to moisture and heat, and these are the and exposure to changes in moisture content. These are the um, types of changes that might occur in our wood when they are affected by these types of natural things. So thank you for that's all for wood. Let's move on to asphalt. So for asphalt, we have here. I think everyone knows what asphalt is. It is also commonly used in the Philippines as pavements for roads. So we'll talk about the definition of asphalt, the types of asphalt, asphalt layers, and also uh, asphalt mixtures, quality control of asphalt, and its advantages over concrete. So what is asphalt? It's a mixture of aggregates, binder, and filler used for construction and maintaining roads, parking areas, railways, tracks, ports, airport, and runways. Mostly, usually asphalt is colored black. So it is a bitumen class hydrocarbonic mixture, typically having dark brown and black color. So how do we manufacture asphalt? First, we got the aggregates, store them in cold feed basins, and then dry them using drying drums, and get the dust particles or the sand particles that are in them by emission control system, and lastly store them before it is being distributed. So is a picture of the manufacturing process of asphalt. First, we pile the aggregates, and then mix them, and then store them in cold feed basins, dry them in the drying drums, and then get uh, filter the fine sand and dust particles from them, and lastly, we store them into the drum plants. So the basic requirement for asphalt is that it is sufficient stiffness and resistant to deformation. It has adequate fractional strength, good workability, and during application. So types of asphalt, we have these types of asphalt are mainly named after their temperatures in which they are being manufactured and used. First, we have hot mix asphalt, produced at a temperature between 150 to 180 degrees Celsius, as we can see here in these pictures. We have warm mix asphalt, which is produced in 20 to 40 degrees temperature, and the cold mix asphalt, which are not heated but uses specific bitumen emulsion, which breaks either during compaction or during mixing. So the asphalt, different types of asphalt layers. First, we have the surface course. Next, we have the binder course. Third one is the base course, which gets most of the load and distributes it. And lastly, we have the unbound materials and its foundation. So this is the picture of the asphalt layer and top layer, which is the surface course, and next layer the base course. So different types of asphalt mixtures. We have asphaltic concrete for a very thin layer, soft asphalt, hot rolled asphalt, soft stone mastic asphalt, porous asphalt, double layered porous asphalt, and lastly asphalt for ultra thin layers. So these are the differences of the asphalt mixtures. Mainly, their differences are because are caused by their gradation. So as we can see, our AC has a well graded mixture compared to SMA, ACTL, and PA, which is not uniformly graded, which has lots of voids here. So the quality control for asphalt, we have their consistency, purity, and safety. Asphalt should undergo a standardized penetration test to determine asphalt consistency when paving. It should be pure. Refined asphalt should be more than 99% soluble. It also needs to have a safety hazard and produce when the asphalt foams due to moisture when heated above 212 Fahrenheit. So its advantages is that it is smooth and comfortable, it is fast to construct and maintain, cost efficient, and it is very much 100% reusable. It is very safe, flexible, durable, and can last long, and it also reduces noise. Its disadvantages, however, is that um, uh, it needs a lot of care and in sealing. It has very environmental issues when making it. It also is prone to cracks, and it also needs heavy equipment and costly equipments to use them. So its advantages over and disadvantages of asphalt versus concrete. So for cost and duration, asphalt costs lesser, but it also doesn't last longer compared to concrete, which costs much but would also last 30 years if properly installed. As for asphalt, it would only last up to 20 years. So for the curing time, concrete needs to take 1 to 3 weeks for it to be properly cured. But for asphalt, on the other hand, it only needs a day or two. So for its climate, asphalt is good for cold temperatures. As for concrete, concrete is good for warm temperatures. So for design, concrete is can be aesthetically pleasing, and you can design it better, especially if you use different types of boards. And also for asphalt, it is not good, and it is not good for artistic purposes. For its flexibility, asphalt has enough flexibility to accommodate errors and imperfections. For concrete, it is not that flexible once it hardens or is already well cured. So applications of asphalt, its transportation, it is used in transportation, mainly in pavements and recreation, agriculture, and industrial. So thank you. That's for all for my presentation for asphalt and wood, and I hope that you have learned something. Thank you and goodbye.